All right. Hi, everyone. Welcome to today's talk, Embracing Productivity Engineering Android. My name is Roger Taracha, and I'll be the one taking you through this talk. So just a brief introduction about myself. I am a senior software engineer, working at Premise Data. I'm based out of Nairobi, Kenya. And yeah, when I'm not coding in my free time, you can find me on the dance floor or doing some event host work. So I'm an MC as well. So yeah, hence my alias, the Dancer Codes. So we can get straight into it. The agenda for today's talk is basically a definition of what productivity engineering is. I'll also take you through how to get buy-in and to make a compelling case for productivity engineering to your manager and to your team. I'll take you through Gradle Enterprise. We were able to go through a trial with them, and right now we are in the process of purchasing it for our company, and how we used it to diagnose builds and improve the build experience. And yeah, some tips and tools on how to improve your Android build. So if you have such questions like, are you currently experiencing long build times? Are you currently working on a project and no one wants to look into the build? Have you inherited an old code base? Like, have you onboarded on a team and you found yourself handling code that's more than 4 or 5 years old? Are you working in a team where the developer's productivity is hindered by the build process? Or are you currently looking to improve your productivity engineering knowledge? Then you're in the right place. This is the talk for you. So let's begin. What exactly is productivity engineering? So productivity engineering is the use of engineering practices to solve problems around developers' productivity. And productivity basically denotes how engaged your mind is on a particular task. So the more time you get to focus on interesting and challenging problems, and the less time you get to focus on repetitive and mindless tasks, the more productive you actually are. So just keep that in mind when you think about productivity, right? And yeah, secondly, productivity engineering is the use of data to optimize software development practices, thereby improving the happiness and enhancing the productivity of software engineers. So you'll note that the engineer's happiness is directly tied to their productivity. So if an engineer feels productive, they generally feel happy with the work that they're doing. And if they don't feel productive, they won't be happy with the work that they're doing day to day. So just keep that in mind as we go along. So just a few more definitions of what productivity engineering is. Generally, it's a culture shift. And by this, I mean that the job of productivity engineering is to improve productivity through the entire life cycle, entire development life cycle from the IDE to production. So productivity engineering is different from DevOps because DevOps is part of the is still involved in the development lifecycle, but it's not end to end, if you get what I mean. So productivity engineering spans all the way from development in the IDE all the way to deployment when you deploy your artifacts to the Play Store or whichever means you use to deploy your artifacts. Secondly, for a team to be successful, it needs a culture where the whole organization commits to improving developer productivity. And this is where buy-in from, let's say, your manager or the rest of the team or the rest of the organization is key. You might have or understand what productivity engineering is and the value that it might have, but if your organization or your team isn't on board, it will be a bit difficult to implement. Secondly, productivity engineering is a bridge. The thing you need to keep in mind is there's a significant gap between how productive your development teams are and their full potential. So there's normally that gap between how productive they are day to day and what their full potential can be. So productivity engineering actually helps to bridge that gap and reduce that gap between their actual productivity day to day and what their full potential could be. So the thing you need to keep in mind is the gap is growing over the lifetime of a project for most organizations, and it can be significantly reduced by productivity engineering. So think about it. As your code base grows, as your team grows, this particular gap between the actual productivity and the potential continues to grow. And that's why it needs to be a constant. Productivity engineering is not a one-off thing that you do, but it's a constant and continuous process that you do often as you go along the life cycle, software development life cycle, and also the lifetime of the product. And finally, it improves developer happiness. The happiness of your developers depends on their productivity, as I've mentioned earlier. And organizations that can't provide such an environment are seeing a drain of talent, leading to even lower productivity. So if you don't create an environment where you developers feel productive, you'll find that they'll leave to find an environment where they feel more productive day to day. And I think this is the last one. Productivity engineering has an economic impact on your business. And this one is key because the economic benefits of not applying this practice can be very dramatic in that the amount of features you can ship is heavily affected by it. So if your if your tool chain is impacting or is slowing down your developers and how productive they can be, you can find that you won't be able to ship features as quickly as possible. And then the productivity gap that comes from not applying the practice of productivity engineering is a significant competitive disadvantage in that if you're in an industry where you need to ship fast and ship quickly to stay afloat, if your competitor is shipping faster than you are, you'll find that they'll be outcompeting you, probably shipping out features faster than you are, serving the customers faster than you are, and you'll find that you actually, in the end, lose revenue, lose sales, and your competition will outcompete you. And this is why productivity engineering is very important in that you're able to ship fast, your developers are productive, and depending on your release cycle, you're able to ship as quickly as possible and be ahead of the competition. Yeah, and that means the productivity of your software development teams is crucial for your business to survive. All right, so we'll switch up gears a bit, and I'll just talk you through the developer productivity landscape. And as you can see, it starts all the way from the left where you have your IDE and it's in the code space, you get into building, then there's testing, CI/CD, deploying, and scaling, right? And as you can see, developer productivity engineering spans from application development in your IDE through the build process and testing, all the way to CI/CD. And you can see DevOps sits towards the end. So it spans from, so productivity engineering spans from application development through to DevOps. All right, and if you're new to productivity engineering, you might be wondering, so how do I start implementing this? What is sort of the mind space I should get into, right? So there's a simple framework that I use. It's 3 main points, and I'll just talk you through those. The first one is identify. So you start by identifying any productivity bottlenecks. So this can be done through sprint retrospectives. When you're going through sprint retros and people are sharing, you can sort of identify what certain productivity bottlenecks are, or you can arrange for one-on-ones with your teammates and just ask them what are some of the productivity bottlenecks that they're experiencing. Secondly, you can ask whether you can ask your teammates whether a task is manual, whether a task is repetitive, and whether a certain task can be automatable. So if any particular tasks meet those 3 major criteria, it being manual, repetitive, or automatable, those are good candidates for productivity bottlenecks. Secondly, you measure productivity. And by measuring it, I mean you measure it in an indirect approach, meaning you focus on the things that negatively impact productivity and try to reduce those. For example, you can measure toil, right? Like if engineers are reporting that they tend to spend 1 hour a week fixing code style violations, you realize that that's one of the things that's actually impacting the engineer's productivity. So they tend to spend an hour every week trying to fix those code style violations. So you can send out a survey or talk to people and then just ask them to estimate how much time they're spending on particular toil. Another example can be around your existing automation, right? So for instance, you spend 1 hour running automated tests on the CI server. You might find that 1 hour might be a bit too long, right? So you can try and fix for that. And in that way, you've identified an indirect approach of the things that are negatively impacting engineers' productivity. Finally, you prioritize according to the cost. So for instance, there are different types of costs that you should consider, and then now prioritize prioritize for that and how you're going to fix it. For instance, there's toil cost, like how much time do we spend on a task every week or every month? And then there's implementation cost. How many hours will a solution take to implement, or how long will it take to automate a solution? Then once you've implemented, there's maintenance cost. So how many hours will a solution take to maintain every month, right? Yeah, because as I mentioned earlier, productivity engineering is not a one-off thing, but it's a continuous process. So you need to factor in maintenance cost. And the last kind of cost that you can think about is onboarding cost. Like how long before a new engineer can perform this particular task? Because as your team grows, as your product grows, new engineers will join, and there's that particular cost. Like how long will it take for them to be able to perform this task? Because you don't want to be the only person responsible for a particular process in the team. That's really dangerous, because let's say you're not around, or if you transition, that knowledge is not passed on to the rest of the team. All right. So now that we have an understanding of what productivity engineering is, I'd like to talk to you about the premise story and how we're able to tackle the productivity engineering challenges we had early on. So for starters, this was the state of our app in January 2020. So our average build times for a PR build were between 30 to 40 minutes. A release build was taking much longer. That was about 15 minutes to an hour. And then our Gradle version was 4.10.2. And this particular Gradle version was released in September 2018. So as you can see, that's already a red flag. We're already almost 2 years behind in terms of updating the Gradle version. And then our Android Gradle plugin was 3.1. We're behind by a year, because this particular plugin was released in February 2019. And yes, we had a broken local build for tests. So engineers could not run their tests locally because it was broken. And our team size was about 5 engineers at the time. And the size of the project, we had about 8 modules and about 187,000 lines of code. So what was the impact of the current state of the project? We had painfully long build times, as you had seen earlier, and then long feedback cycles for test feedback. So for instance, you'd find that you create a PR and then it starts running the test. So it takes about 30 to 40 minutes for it to fail and give you that feedback. So our feedback cycles were really long, and yeah, engineers were not as productive as they could be. Then we had long wait times for merging PRs for QA builds to be distributed, because we were distributing our QA builds to Firebase app distribution, and also our release candidate builds. Whenever we'd cut them, as you'd seen earlier, they'd take about 15 minutes to an hour, and that was just too long. And then this was significantly negatively impacting our engineers' productivity, because you'd find that someone creates a PR and then has to wait 30 minutes. So you'd find that they get out of flow and they have to go and start focusing on something else. And this wasn't ideal, right? And then we had flaky builds as a result. So you'd find that our builds on master would be broken very often, and master should always be releasable. So that wasn't working to our advantage. And sometimes because of the long build times, we would experience build timeout. So you'd run a build, it would run for about 50 minutes and then it times out, and then you have to restart it. So you'd find that engineers would lose about an hour, 2 hours, 3 hours per day just waiting on builds. And that's not ideal. Weren't being very productive. Yeah, so enter Gradle Enterprise. So earlier this year, I think in about April, we reached out to the Gradle team, and we were able to get on the Gradle Enterprise trial. And this experience was really valuable because they helped us improve our build experience, they really helped us improve our build experience. So these are some of the highlights from the Gradle Enterprise trial. We're able to install the Gradle Enterprise server, which I did. I created a GCP instance for the same. Then we started by collecting baseline data using experiments and then viewing it using build scans. And basically baseline data was us turning off any build acceleration technologies we had, whether it was local caching or remote caching, just turning it off and then getting the baseline data to understand what our build times were without any improvements. Then from there, we ensured that we had a proper configuration. We configured our project ideally, and then we reintroduced the local and remote cache. And then finally, we also implemented cache node replication. So in the next slides, I'll just explain some of these. So we started by really diving deep into the build scan. So build scan is one of the technologies offered by Gradle, and it's a simple Gradle task. You just append --scan to your Gradle task, and it will be generated for you, or you can add it to your Gradle file, and you'll be able to access your build scans. And for more information, you can check out that link, scans.gradle.com. And that's what a sample build scan looks like, right? So you're able to dig deeper into performance tests, how your project is set up. You can get all that information about your build in the build scans. Then secondly, we introduced build caching. So build caching is another acceleration technology that helps you reduce your build time significantly. And in case it basically helps you avoid doing unnecessary work. So if you run a particular build and nothing changed, you can reuse inputs, you can reuse the outputs of the previous build as inputs and significantly reduce your build times. So I'll just talk you through how it works. As you can see on my screen, there's a diagram, and there are three main processes. So basically, Gradle has three layers of reuse that prevent potentially expensive tasks that I've mentioned. So for the first case, as you can see there in number one, in between consecutive runs of a Gradle build by developers, usually many things don't change. So the Gradle incremental build feature will only execute the tasks that are not up to date. So if there are any tasks that are not up to date, those are the ones that will be sort of executed. And then secondly, there's the local cache there. So for this, you note that developers typically maintain many workspaces or work on many branches that perform distinct tasks, right? So the local cache allows outputs to be quickly reused across workspaces or across different branches without having to change networks or having to rerun those particular tasks. So that way it improves your build speeds, in that if you're working on a particular branch and switch to another one, it will just use the outputs that are available in your local cache. And then finally, there's the remote cache. And basically, it's a CI node. So basically what happens is the tasks that you run locally and the tasks that are run on CI are often the same and use the same set of changes, right? So the remote cache allows outputs to be reused across different developers' machines or computers, and also the build agents, right? So if the two, let's say your local cache is not available and you'd like to populate it, right? Let's say at the beginning of the day, you run your initial build. So it will pull the changes from the remote cache into your local cache, so you're able to use them. And that way you find that your remote cache is a single source of truth, in that developers don't make changes to that one, but it's only the CI agent that makes changes to that particular remote cache. All right. So yeah, that's what I'd mentioned earlier on, and we'll proceed. Cache node replication was an interesting one, because once we set up our remote cache was set up in East Coast in the States, but our team is distributed. So we have some engineers in West Africa, some engineers in East Africa, some engineers in Northern Africa in Egypt, and also some in India. So with cache node replication, we're able to create we're able to help improve build cache speeds and reduce the round trip to the main cache node server. So we had the main cache node server in the States, but we set up replication servers closer to the engineers in their particular locations. So it would just basically create a replication of the main cache node and reduce that round trip. So if I'm in Nairobi, I don't have to ping the server that's in the States, but I ping one that's closer to my location. And this is sort of what it looks like. As you can see, the first line there, it says the built-in. So that's the main cache, and then the other three are distributed across locations. So you can see there's the East Africa node, West Africa, and then the US West Coast node. All right. And then let's now dive deep into the improvements that we're able to achieve at premise, right? So for starters, our average build times went down from 23 minutes to about 8 minutes per build, which was significant. And then now the local build times went down from 3 minutes to about 1 minute per build. And then we used build scans to really diagnose, collaborate, and fix build issues. So a build scan is really, really important, because if you're facing a certain issue, something broke, and you want to directly point your teammates to what the issue is, you can just share with them the build scan, and they'll be able to look through it. And you'll find that the turnaround time for collaboration and fixing issues really went down. And then we also discovered incorrect heap size configuration that was causing high garbage collection. And we find sometimes as a result of this, some of our builds would time out. And then we also discovered mismatched JDK spawning for multiple daemons. So this one, we actually were able to discover this using a tool called Gradle Doctor. And I'll talk about it later in the slides. And then other improvements we were able to also achieve is we found that a large portion of our tests were disabled for the project. As I mentioned, we inherited an old code base, and the early engineers had disabled certain unit tests. So certain parts of the code weren't ideally under test. And as you can see, that doesn't improve your confidence in the product as an engineer. And then we also found that less than 10% of our unit tests were accounting for 60% of the test execution time. So the test output, what we realized is we had a small set of roboelectric tests that were extremely slow, and this was greatly reducing the build times, and also signifying some code smell in how our tests were constructed. So ideally, roboelectric tests are slow, so we had fewer tests that were taking much of the execution time, and this was an ideal, right? And then we also uncovered some inefficiencies in our build task configurations. And we also uncovered some inefficiencies and duplications in our QA release and build distribution process. So, and this was done by examining the build scans that helped us understand that we're generating multiple sets of APKs for single build and then distributing this to multiple locations. And this was an ideal because it was really taking a lot of our time, right? And then, the final one, which was an interesting one, we're able to discover some build regression because we introduced some native code. And this actually sort of increased our build time. So we were able to catch this when we observed the build times, the build trends on our build scans, and we were able to also work to improve this. Some of the other things that we were able to make improvements to our project were around failure analysis and the resolution of local and CI builds. In that we're able to collaborate on build issues with build scans, investigate the build failures, and also investigate the slow builds, all via the build scans. And then we were able to accelerate the feedback cycle. As I mentioned earlier, our feedback cycles were really long and 30 to 40 minutes. And once we went through this process, we were able to improve those build times by shortening what the feedback cycles were. And then we're able to diagnose and improve the build cache performance as well. And then this was a big win for us in that we got some insights for switching CI providers, because we realized when we were using Travis at the time that the queue time was taking much of the time, right? So we're waiting for Travis to spin up, and it was taking about 5 minutes, which was a really long time to wait before now our builds kicked off. And then we were able to enable certain changes. With better observability leads to more confidence in making changes to the build. So before we weren't able to understand how our build was working, but once we were able to use Gradle Enterprise and dig deeper into how the build was working, we had even more confidence in making changes to the build and making changes to our code, because we're able to observe the impact that our changes to the code and the build were having on the project. All right, so let's dive into the tips and tools to improve our Android builds. And for starters, this is one of the main ones, or rather the low-hanging fruit. Just make sure you update all your dependencies. Make sure they're all up to date. Remember when I'd mentioned earlier, when we picked up the project in January, our Gradle version was behind by 2 years. So we're missing out on some of the new performance improvements that were in the newer versions of Gradle. The following. Latest version of Gradle, the Android Gradle plugin, Gradle Enterprise plugin. For those who are using Gradle Enterprise, just ensure that it's the latest version. Kotlin as well, and then any third-party plugins and third-party libraries that you may be using, just ensure that you're using the latest version of the same, because they'll constantly be making improvements that would result in you improving your build times and your build experience as well. And then there's a Gradle versions plugin that I'd recommend. This plugin provides a task to determine which dependencies have updates. So if you find it hard keeping track of which plugins or which libraries are up to date or which ones have updates, you can just leverage this particular plugin. It also checks for updates to Gradle itself. So this is the Gradle task that you'll run. It's dependency updates dash revision equals release. And that's the link to the particular plugin. So just check it out, add it to your projects. Then anytime you run that particular task, it'll let you know if any of the plugins or any of the libraries have updates. Yeah, next is the Gradle Doctor plugin, which I'd mentioned earlier. So you can use this plugin to identify and address any issues you may have in your project. And then it will give you configurable warnings for build speed problems. And then you can ensure that your Java path is set in your project matches that in the IDE. So this is normally a major issue. You'll find that your IDE Java home path is different from what your machine has. And then it sort of sets up two separate daemons, and that affects your build speed. So you can keep that in mind as keep that in mind when you install the Gradle Doctor plugin and run it. If those paths don't match, it will fail the build until you fix it, which is actually good. So you can use that URL to access it as well. And then get buy-in from major stakeholders. So you need to get an understanding and get buy-in early from the major stakeholders by communicating the value of productivity engineering. And you can do this by doing small experiments that clearly communicate the value. And this is what we did early on. We did something simple as just updating the dependencies and then integrating the remote cache. And this significantly reduced our build time. So when we were comparing the project before and after, we shared the data with our engineering manager, and they saw the value. And after that, we were able to create tickets and just push for us to continue with work in the productivity engineering space. And then, as I mentioned earlier, you just share your findings with the major stakeholders, which would be your manager and your team, so that you can get buy-in on the same. And something you need to keep in mind is that productivity engineering is tech debt. So it's something that you need to plan for. All right, you can see time is fast spent, so I'll go quickly through the remaining slides. The second thing you need to keep in mind is your operations process. So for us, we have an engineering needs sync, which is bi-weekly. And we just discuss any needs that we need to address before sprint planning the next week. And during the syncs is when we get to prioritize some of the tech debt and productivity engineering tickets that we need to work on. And then now we create an epic on Jira, and that epic in our case is called Android Build Performance, where we might add any tickets that need to be addressed. So yeah, that's like our bi-weekly calendar invite for the same. Build caching is another place where you can get significant gains in your build. So as I'd mentioned earlier, you can integrate the local build cache, remote build cache, and a combination of both can significantly improve your build times. And if you can see on the screen, it might be a bit small, but before caching, this was one of the tasks. It took about 18 minutes, but once we integrated caching, it compressed it all the way down to 17 seconds. So that's the beauty of integrating build caching in your projects. All right, so this is another plugin. It's called the Android Cache Fix Gradle plugin. So some Android plugin versions have issues with Gradle's build cache feature. And then this results in build cache misses for some tasks affecting build speeds. So when this plugin is added to the Android project, it applies workarounds for these issues based on the Android plugin you're using and the Gradle version. So one thing you need to realize is cache misses impact your build speeds. And this particular tool helps mitigate some of those issues. So you can just add it into your project and observe the improvements to your build times. All right, so GitHub Actions is another thing that we integrated. As I mentioned earlier, Travis wasn't ideally working for us, and we decided to migrate to GitHub Actions. So this was actually a big win for us. And the results were improvements in the CI build pipeline, and also we're able to run the full test suite for every PR, and it wasn't taking as long as it was on Travis. So yeah, that's a screenshot of what the pipeline looks like right now. So we run test, linting, and assemble in parallel, and then there's also a notify build status of the same. And then team education is also important in that you should make benchmarking accessible to all, and make Gradle Enterprise accessible to all. So basically what I mean by this is any work that you make in the productivity engineering space, you need to make this accessible to all your team members. And documentation is one of the key ways you can do it. But also on our team, we have lunch and learns where we have 30 minutes to an hour sessions where we get to share the work we've been doing in different spaces. And then the team gets to understand this and also just ask any questions that they might have. So there's that knowledge share that happens among the team. So others that you can think about, there's configuration caching and file system watching. These were introduced in Gradle 6, if I'm not wrong, which actually help significantly reduce your build times as well. And then you can also update the amount of memory allocated to CI builds, which is something we did as well. And we saw an improvement in our build times and less timeouts as well. And then IDE optimizations. And for this, you can update your existing plugins or develop plugins of your own to improve your IDE optimizations. And as I mentioned earlier, productivity engineering spans end to end. So from development all to deployment. So if you can get some wins in the IDE optimizations, that would be great as well. And then, yeah, we are at the tail end now. So this is our upstate as of December, as of this month, actually. So our average build times have reduced significantly for PR builds from 30 minutes to 9 minutes. That's a big win. For release builds, it's down from 50 minutes to 15 minutes. That's our Gradle version. They're current right now. Our team size grew from 5 engineers to 9 engineers currently. And then the size of our project as well, from 8 modules to 10, and the lines of code also increased. So what are the final takeaways? This is what you need to keep in mind whenever you're practicing productivity engineering. You need to measure what you want to improve. So that's the only way you'll be able to communicate value to your team members. So remember to measure what you want to improve. And then productivity engineering is tech debt, so you need to plan for it. And this is what we experienced early on in our project, in that feature development will always take priority over tech debt, but productivity engineering and just improving your builds will actually improve productivity and help you ship your features faster. So if you can find that balance, prioritize for it, in the long run, you will get great gains once you implement it in your teams. And then you need to use experiments and data to get buy-in. As I mentioned earlier, just run some small experiments, get that data, share it with your team, share it with your manager so that you're able to get buy-in on the same. And then use the available build speed acceleration technologies that are available to you. Build scan, build caches, build caching, there's the configuration caching, and all the new tools that Gradle keeps adding to the tool chain into their products. Just make sure that you're up to date. Yeah, then productivity engineering is a continuous process and not a one-off event. So it's something that you need to constantly keep working on, because you'll find that when you add features to your code, that might cause some regression. So you need to keep fixing, keep improving your builds as your project grows. And yeah, that's it from me. If you need to reach me, the Dancer Codes, that's my Twitter handle. And yeah, I think we'll open it up for questions. I think we have a few minutes for questions right now. All right, so I can see some questions here on Slido, so I'll just read them out. Have you used remote build caches without Gradle Enterprise? And if so, what are the limitations? That's a good question. Yes, you can use remote build cache without Gradle Enterprise. The only limitation you have is the depth of the insights that you can get in terms of debugging your builds. Because with Gradle Enterprise, you're able to do build scan comparisons in that when build scans are generated between builds, you can see the different build scans, and then you compare the two and you're able to see what the differences are, and you can dive deeper into the data, and you're able to resolve any challenges that you might have. So that's majorly the only limitation, in that you might be limited in terms of the amount of data that you have about your specific builds. But in terms of acceleration, you will get the same sort of, what you call it, you get the same optimizations or build speed gains, because the cache node is the same. What Gradle Enterprise does is that it just gives you the ability to be able to see the different build scans and the trends of your particular data. All right, second question, what's the relation between updating library version with Gradle build speed? So the relation is this. The example I gave you was this. Our Gradle version was really outdated. It was 4.10.2. That was, and that version came out in 2018. Most of the new acceleration technology, like the build caching, some of this configuration caching technology have come out in the newer versions of Gradle, Gradle 5 and Gradle 6. So you find that if you're using an old version of Gradle, you're missing out on the build speed improvements or the build acceleration technology that is available to you. So that's the relation. Any tips about caching, like how to decide what, sorry, let me just read that again. Any tips about caching, like how to decide what I think you believe what you need to cache. All right, so for starters, something that normally takes up a lot of time is tests, right? So you can start by ensuring that your tests are cacheable. But one thing to note is currently, it's only unit tests that are able to be cached. UI tests, for instance, espresso tests are not cacheable. And you just need to be smart about that. So you don't need to run UI tests for every build, just run them maybe when you're cutting your release build, but for maybe PRs or maybe also nightly builds. But for PR builds, you might not need to run it as often as needed. But for starters, test is what normally takes a long time. Configuration time. And when you look into your build scans, you can see how long your configuration takes. So another tip for caching is you can leverage the configuration caching that has been added in one of the latest versions of Gradle, should be Gradle 6.7 or 6.5. So that's one of the other tips you can use. So one of the things you need to do is identify the tasks that are taking a long time, and then figure out whether those can be cached, right? So that you can have significant gains in your builds. And I believe that's it, unless there are any other questions. Thank you for making the time for coming for this talk. I hope you found it useful. And in case you have any other questions, you can find me in the chat rooms, or you can find me on Twitter at the Dancer Codes. That's it from me. Over to the droidCon team.